Hey. Today we are going to solve search a 2D matrix. It's kind of a nice problem. We are going to search a target value in this matrix or grid, whatever you are calling it. Let me read you a problem statement. You are given M by N integer matrix. The following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. It's kind of nice. Means like 1 is going to be less than like 10, 10 is going to be less than 23. Right? Given an integer target, return true if the target is in the matrix. If you got it, like we're going to return true, otherwise we're going to return false. You must write a solution in log m by n, or it means like you can brute force it. Like if you are trying to brute force a matrix, it's going to take n squared times. Yeah, it's about okay. If we can't brute force it, we can write some binary search for this matrix. The first thing we need to do is we are going to binary search for the column. We are going to pick the last element of the first row and the first element of the last column, and we are going to ask like question like that in the binary search. That's how binary search work. If the target is greater than the last element of the first column, like we're going to increment it. Otherwise, if the target is less than the first element in this row or the last row that's not like that's the last row, we're going to decrement it. That's how we're going to do it. Otherwise, like we are going to pick that row. If the target doesn't exist in this scenario, we are going to return false. After that, if you are picking the right column, we are going to search. We are going to run like another binary search for that row. It means like we are going to create left pointer in and right pointer in, and we are going to run another binary search. We are going to ask the same question if the target is in here, blah 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 blah. I'll show you in the code. Let's start with, let's print our row and column. It's going to be length of matrix of first element. The next thing we need to do point is our top and our bottom. Our top is going to be 0 and our bottom is gonna be column -1. That's how we're going to get our first top and bottom. While we're going to binary search it. Top greater than the bottom, we take the middle point. Let's call it row. Our row means top plus bottom divided by 2, means like our middle row. If in that position or our target is greater than can matrix of row of, if the target is like greater than the last element of the first column, means like at this time if the target is greater than 7, what we are going to do it, we need to increment our row. Row should be incremented by 1. otherwise our target is less than matrix of row the first index. What we are going to do, row should increment. If target is less than first elements of the first index, what we are going to do? What we are going to do, we're going to decrement. You need to move, they need to decrement like this way one. Else we are going to break this loop. It means like if you got it. If not, top is equal to 10. If this is break and if doesn't satisfy it, we are going to return false. Okay. After that, we need to make sure our row is in the middle point. Okay, let's print our left and right pointer in that row. What we are going to do, our left pointer is gonna be 0 and the last element, our right. That we are going to write some binary search in here. Let's take our middle point, left plus right, divide by 2. Taking our middle point, we are going to ask the same question. If our target is less than target is greater than matrix of middle point, that's gonna happen. Our left pointer, yeah, if the target is greater than the middle point, what we are going to do? Our middle point is gonna be incremented by 1. Else target is less than matrix of middle point. Our right pointer is gonna be decremented by 1. Else return, otherwise return false. False. That's how we're going to do it. We are going to run 2 binary searches for the column and the row for the matrix. Kind of nice problem. That's why I like it. Exit, time complexity, what we are going to miss. What am I missing? Okay, let's check from the beginning, row and column and bottom. If top is less than bottom, let's run some binary search row. Oh, why am I doing like this? It's gonna be top's gonna be decremented, it's gonna be bottom. It's kind of, I just incremented the rows. Kind of other typo. Matrix. Same way I missed here. Matrix. listen like you get the concepts behind the word. Index out of range. Okay. If target is greater than the matrix for in minus 1, our top is going to be our middle. What am I missing? I didn't get it. Oh, it's list out of index. Like our binary search is like perfect. Should I change this thing into okay? Top plus and minus top. Okay, did I miss? That's my mouse. And do this. Avoid, I think, list out of index. And some brackets. Right. Still there is some list out of index for same thing in here. Ooh. Left plus sometimes you are working with binary search, like this kind of error is like common to avoid list out of index. Right, minus left. That's some wrong answers. Oh, we are returning false for why? We should do that. And then again. No idea what's wrong with this code. There is some bullshit in here. Should it examine quality? With something wrong in this code. Let's get back to the previous one. Should work at this time. I didn't get what am I missing. Then it's not going to be this one's color. It's gonna be wrong. That's my mistake. Damn.